Zico Smart and Alexander Davis. So we actually bought the house and we put it together and we attached lights and fans and music. We used OpenHat, which is an open software web server where you can create your own sitemap for each local host. Say you want to set a sitemap for work, set a sitemap for home, set one for a friend's house, and wherever you go, you can connect to that sitemap and use each setting to turn on specific lights, to turn on a specific radio, and to turn on the fans. So what we started with first was the software, and I'm going to have Zico to discuss the software.
Yeah. Okay, so my name is Zico Smart, as you said. OpenHive is a web-based server, so the whole idea was that we create an environment and we added a couple bindings to this environment. The bindings we needed was the GPIO pins, the InfluxDB, which is a database type system, and the MQTT, which is a messaging type system. So the whole idea is to relay output from the Raspberry Pi to the certain devices in someone's house. So example, I want to send a message to the lights. I simply
And when he sends a message here, you see
the InfluxDB moving.
Running.
Yeah. So that monitors the code, and that monitors, it has a refresh rate of like 1 minute. So every minute it'll refresh the code, it'll keep on refreshing the signal, and as you see, the lights will constantly be on. And okay, so as you can see, the app.
Yeah.
The app, we made with the OpenHive, as I said, we could create an environment. So in this environment, we could also create multiple different sitemaps, multiple different code that say like you have a local host at home you want to connect to, you can connect to that local host. You want to connect to a local host at work, you can connect to that local host. And if you have devices at work that you want to control, you can also control it through OpenHive. So I'm gonna pass you guys to Portia so she can demonstrate the music.
Ooh.
My bad.
So it's lights, fans, and music
Lights,
right
fans,
now.
and
Okay.
music. Like, yeah, my bad.
The fans.
They work 1 minute.
Yeah.
Then
it
they
was
don't
really-
work. Like we get the circuit to work. We used an IC chip.
Bless you.
I think it was an AND IC chip to get the fans to
So
work.
you can-
But
you
they
can-
work on and off. Sometimes they turn on.
There's like a multitude of different, bindings you could add. You have like, what's it called? The hue lights. You have Sonos, which is like speakers. You have, you could connect to Google Chromecast. You can connect
Pandora,
to your Xbox.
Spotify.
Yeah, and it goes on. So based on the device, so you could like play a song.
So where's the circuitry? So
When your legs don't work like they
that connects to what? Yeah. It's sending it
this
to
connects to the local host, which is the router.
the router.
So
Okay.
the router is a local host. That IP address is
Okay.
connected to the same the iPod, and that IP address is connected to the Raspberry Pi, and that IP address is connected to the computer.
Where's the Raspberry Pi?
The Raspberry Pi is below the. Yeah.
When Alex discussed the hardware, we're
We're
gonna
gonna
show.
show it.
so
Okay.
I'm gonna pass you guys to Alex. So you can
Okay, Alex, discuss the hardware. Yeah.
All right, hello everybody. I'm Alexander. It's good to see some familiar faces. I'm here to explain the hardware version, part of this project. As you can see, there was a lot of wiring involved. We try to make it as neat as possible, you know, because in a real life application, you don't want wires hanging out everywhere. So you can see most of our wires come down, and our Raspberry Pi and our breadboard is actually underneath the house. As we built the house, we actually built extra foundation. This right here is an extra foundation so that we can house our Raspberry Pi. Now, we also had, these fans are supposed to simulate ventilation. Unfortunately, we can't get them to work today. We had them working a few hours, last week, a few hours ago, but it could be loose connections or something like that. We actually had a lot of trouble with that. At first, we were using many different components, transistors, diodes, and we found that a lot of our transistors were burning out. So with the help of the professor, we actually end up using an IC chip, the SL5441, and yeah, which is right there. And with that, we were able to make the fans work and power all 4 of our fans with just that one chip. Now, also with the lights, as you can see, we have LEDs, but in a larger scale, this would be something like the new Philips Hue.
Yeah.
Whereas, could you turn on I like to call the disco room.
It's on now.
It's on?
They can't see
Oh,
it.
but
They can't see it because it's flipped.
Well, you probably saw it earlier. The lights actually change color, and that's supposed to simulate how the Philips Hue works. And as you can see, this is circuitry. This is our Raspberry Pi. Each one of these are different GPIOs that actually goes to our fan. This is our fan circuit, and this breadboard is actually our lighting circuit. So we kept it.
as far as the music, where is the music present? In the Pi?
No,
No.
It's
Connected
in
to
the Sonos.
it's in
Oh,
the
in the
Sonos.
Sonos,
So
okay.
So
what
we
we did was we piggybacked off that stream.
Yeah.
And so since we piggyback off that stream, we can manipulate the connection. So if we wanted it to turn off, we could get it to turn off if we want the next song.
So the Sonos connected to the router,
The Sonos is connected.
not the Pi.
to the
Okay.
Pi. Once everything is
Okay. So the
And the Open
Sonos
Hub
and the
is
Open Hub is connected to the
The
router.
router
Okay.
as well.
Okay. Cool. Great job. Any questions?